Now it's recording. Now we can go to share screen. Okay, so let's go back to this. Okay, so let's do the opening activity. So the opening activity, first off, you got to remember everything you need to know. And if you, I don't know if you've noticed this, I post stuff every day. So like, for instance, I posted this today about day 7, just a little reminder in case you forget. I also put my grade 12 classes on here too, so ignore them. So today is chapter 5, integers. Just a reminder, well, it would help if I could spell. Just a reminder, assignment 2 is due by 8 tomorrow. I'll fix that after that, oh boy. And then everything else you need is on here. So if you go to the contemporary math, right, all the course materials, here's all the assignments, assignment 1 through 5. So you can print those all off ahead of time. Now, the midterms next week, and you'll probably need the formula sheet. So make sure you print that off ahead of time if you get a chance to. So if you can link on the formula sheet, it'll link you to the formula sheet, and it's 2 pages. I think it's 2 pages. You might need that. I can't remember of the questions, but you might as well, you'll need it for the last one anyways, and other tests anyways. It's good to have. So we are doing, what are we, Wednesday, May 12th, right there. So we're going to start with the activity called num square. So if you printed this off, great. If not, you're going to have to maybe draw a little picture to do this. Now, this is a puzzle activity again. So what you're going to do is on these outside corners, the 4 corners, right? Top left, top right, bottom left. You can place any number. Okay. Then what you're going to do is, for instance, let's say you had a 5 in the top left and a 2 in the top right. In this middle one, you're going to write the difference between them. Okay. Then, you have the top left and the bottom left. You're going to have a number there when you find the difference. So then you have 2 numbers here, and then you're going to find the difference. So you're going to keep subtracting and keep subtracting and keep subtracting. And the object is to avoid ending, see the 4 in the middle here? You want to avoid having zeros there. So for instance, I'll give you a little hint. If you start with 2 low, like let's say you started with a 2 and a 3, those numbers are way too low, right? Because when you subtract them, you're going to end up with a 1. And then when you subtract from something else, you'll end up with a pretty small number. So you might have to start with a little bit bigger numbers than you think.
Okay. Do they have to be single digit numbers, or can they be double digit?
Any 4 numbers. Any 4. Okay. So you can pick whatever you want, but you're doing the first, what it is the first 4 on the outside. Top left, top right, bottom left. And then you'll just keep subtracting as you go down between them. Give it a shot. Maybe do it in pencil. And I'm going to finish doing attendance while you're doing that. There's Tyson T. I see that. Where are we here? These people are absent. Oh, there's Terrence. Got him. Farah's here. Got her.
I just left for a moment. My audio was acting up.
Yeah, no problem.
But
yeah, if you need to restart the computer, then go ahead, do that if you need to. Who are we missing still? Let's double check. Heather Burns, is she here? Let me look. I don't think Heather's here. Nope, no Heather. And Kayla George, is she here? Kayla. Nope. And I think Brooke, unless I missed Brooke. Let me look. Brooke.
I have a question.
Yes, Eric.
So my final four numbers are all the same. Is this always the case?
No, I don't think so. But are they zeros?
No, they're all twos.
No, perfect. Okay. So you started with, did you have to start with pretty big numbers on the outside?
Yep, I started with a 99, a 39, a 12, and a 5.
Okay, good. Good. Other people are still working through it. So, I mean, what you do really, if you were giving this to somebody, I gave you more instructions that I probably should have. Like you just say whatever numbers and subtract. So you don't tell them that maybe they should start with larger numbers, but you can kind of give it as a wide open thing. And then you might have to give instructions later on. Okay, so start something like, start with double digit numbers, right? And, make sure that you have a small number and a large number to really make a good difference between them, right? You can get to those things later on, but you don't need to start with it. You can kind of leave it wide open. Like open-ended questions. A lot of kids really dislike open-ended questions, but they're actually pretty good.
I personally hate open-ended questions because I like really defined parameters.
So you'll find it's tough to not find a math teacher that really likes that almost concrete sequential, right? They like rules, like they make lists, they do stuff, right? And if you can find math teachers that are like sequential, but let's say instead of concrete, more abstract or random, you can actually get some really cool math stuff going on because they think differently, right? Time is it? No, we still got time. Anybody else get to the center without zeros? Or did you all end up with zeros and had to erase a few things?
I ended up with zeros.
Did you end up with zeros? Yeah, so then you got to go back and erase a few things and try again. And you might alter your strategy, right? Just slightly. I'll just give you, do you want just a couple more minutes or? I know some of you like puzzles. Some of you probably hate puzzles.
On one side, I'm okay, but not on the other side.
Sorry, what was that, Alice?
On one side, I have 5s, but on the other side, I have 0s.
Oh, there you go.
It's a good strategy game.
Well, that's what you're trying to figure out, right?
I can see the kids loving it. Yeah, I got it.
You got it without zeros now? What is this one? I can't remember how many. Another short one again, too. Some of these lessons are really short. That's good though. Gives us more practice. Okay, let's swap that out. And we're gonna then we'll do the PowerPoint in a second. Now, just a reminder. Remember, there's one thing at the end of the course. Well, besides the final exam, there's one thing that's like, really, to be honest, it should be just a solid free 5%, and it's called the learning activity, right? Remember, you are going to find either a game or activity, right? And you do not have to do this from scratch. You can use an existing one, right? If you have something, don't use one of mine either, by the way. You can't repurpose like, oh, here, I'm going to do sum it up again. No, don't do that, right? It has to be individual, it has to be a new one, something. And it can be on, for instance, you can read here, right? Related to math and any other subject area. It's really nice if you can get crossover ones like math and social studies or math and phys ed or math in a different language, right? That's really useful. And we will probably not have time for a short 3 to 5 minute presentation because there is 30 of us, right? So basically what it is on that day, I'll say, okay, Justin, I'm going to use you as an example. Justin, what's your game? And then you'll just tell us what the game is, and then we can link it on the screen. Because actually, what I can do is I can give you control of the screen, and then you can actually just on your computer throw up the game and activity. And then you just do things like this. It has to have your name on it, the name of the game or activity, the overview, the grade level, the list of materials required, whether you actually have to buy something or you can just find it in your class. Clear directions and modifications and adaptations, right? That's really important. Can you help students who are not or need to be adapted? Can you give them some points? And then you can see how right here's the rubric, right? It's the basic thing. And it's 5% of your mark. So if you find a good one and just answer all those questions, you're going to get 5 out of 5. Well, whatever it is out of whatever, you get 5% is what it is. Okay. And I've been trying to do it like all the stuff I based on, like every single time we start a day, I'm giving you an activity. Those are good ideas, and they're going to range from all sorts of things, right? Like, what did we do? Binary number, magic trick, sum it up, 100 wipeout, get from point A to B, the math journals, and then today we did num square. Tomorrow we're gonna do one. You're gonna go like, what the heck are we doing? It's called the weird wheel. You'll see that tomorrow. Okay, let's do the PowerPoint here. Let's stop sharing that. Hit the PowerPoint. Here we go. Share screen. Come on, share screen, you stupid thing. There it goes. Oh, sometimes it doesn't work. There we go. And slideshow from the beginning. Okay, so now what we're gonna do is we're gonna do integers. Now, if you remember, I think we did whole numbers yesterday, correct? Whole numbers, which was 0, 1, 2, 3, 4, all the positives. Now, integers, right? Integers is all, well, you can see whole numbers, W, 0, 1, 2, 3, dot, 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 go on forever. Well, integers are all the stuff from negative infinity to positive infinity. So it's all the negative numbers, dot, 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 -3, -2, -1, 0, 1, 2, 3. And it's all the other stuff going to positive infinity. Okay. Well, there's a couple of rules that we have to talk about when we're dealing with integers, because they help us do then when we get to adding, subtracting, multiplying, and dividing, we'll deal with absolute value, when we deal with algebra, all that stuff. So this is right out of the textbook. Integers are all the negatives and positives. Natural numbers, right? Remember, natural numbers are the first ones we start with. Counting numbers, they often call, because we don't use 0, 1, 2, 3. We have our negative numbers. Here's a question for you. 0, is it positive or negative? What do you think? It says right here,
Neither.
it says right there, right? It's neither, right? It's kind of one of the, it's kind of like when we did prime numbers yesterday, right? Remember, we had prime numbers and composites, but one was an exception, right? One is not a prime or a composite. It was called a unit, right? There's always that one variance in there. So 0 is neither positive or negative. Now, one of the most important principles in integers is called the additive identity, or additive inverse. And you'll sometimes hear teachers calling it adding the opposite. I don't know if you've ever seen that. That's something they talk about. So additive inverse, oh, sorry, back that up there. Additive inverse is, well, first off, let's do the zero one first. If you take any integer, just the same with any, remember, whole number yesterday, anyone, if you add 0 to it, you always get what it is. So for instance, if you take 5 and add 0 to it, you get 5. If you take -7 and add 0 to it, you get -7. So that is the additive identity for 0. The additive inverse is, you can see there, it doesn't matter the order. If you have a positive and negative, you can flip them around, right? So 7 plus -7, or -7 plus 7 will always give you 0. Okay, so keep in the back of your mind the additive inverse rule, because we're gonna talk about it as we go along here. The next ones were, so that was, hang on, let's back that one back up again. Already back, oh, that's wrong, back up. This was a positive and negative is the same as a negative and a positive, as long as the numbers are the same. This one is, if you have two different numbers, the additive property still applies, in that it doesn't make any difference in the order, right? 2 plus 3 is the same as 3 plus 2. Now that's for whole numbers. That also applies to negatives, right? -5 plus -7 is the same as -7 plus -5. Makes no difference on the order. Okay, now this is the one people were asking me about yesterday, and I said, just hang on, we're getting it to today. You know, I didn't want to ruin the surprise, because, you know, math is all about surprises. Absolute value. The absolute value is basically, I don't like the word magnitude. It's kind of a, well, I don't like that word. I like it as a kind of a definition as the distance from 0, right? So for instance, the number 5. How far is it from 0? It's 5. But if I asked you, hey, how far is -5 from 0? Well, you don't say it's -5 from 0. It's still 5, right? It's still 5 spaces from 0. Okay. So when we're talking absolute value, and we define it with, you can see these straight up and down lines, like brackets, like straight up and down brackets. That's what defines absolute value. Okay, so let's look at, I think we have some examples here. Oh, they're already given out. Okay, so the absolute value of negative 71, right? If we were to draw lines around that negative 71, what is the distance of negative 71 from 0? It's 71. What's the absolute value of 29? It's 29. Here's one. What's the absolute value of 0? Well, 0. It's not going anywhere, right? And the absolute value of negative 852 is 852. So it's the absolute value from different directions. Okay, so now how that applies, hang on one sec here. I want to throw something up on the board, on my smart board here. Give me a sec. Just let me pop it up here on the smart board. And then I want to talk about this because this is what people were kind of struggling with on some of the questions here. Ooh, I need that one and share. Sorry, I got to actually turn on my smart board. That would help. You guys can see it, but I got to turn on the overhead. Just give it a sec here while it's turning on. There we go. Okay. So this should help you on some of the questions that are on the assignment. So for instance, if I put the absolute value of -5, what does that equal? You can turn on your mics because I can't see from the screen. What's the absolute value of -5? Sorry, what?
5.
5. Correct. Now, here's the deal. There's more than one answer here because watch. If I ask you what is the absolute value of 5, what is it?
5.
Okay, so there are 2 ways to get an answer of 5. So when you get a question like in the assignment that says something like this, what is the absolute value of X that equals, let's say, 31? I don't know, I'll just make up a number. Okay, so here's and what we want to know is what the heck is X? Well, is there more than one answer? In fact, there's how many answers?
2.
There's 2 answers, right? So what is it in this case? If I gave a question like this, how many actual values of X are? There is, what are the 2 answers?
31 and -31.
Sorry, what was the first one?
31
31 and
-31.
31. Excellent. There is 2 answers. Now, do any of you remember the shortcut way of writing this? You don't have to write it this way, but this is the shortcut way. How do you show that something is both positive and negative? Nobody? All right, I'll write it down.
Absolute value? Or
No,
just-
yeah, I see what you're doing. No, this is how you would write it. You write it as X equals plus or minus 31. You guys ever seen that before?
Yeah.
Okay, that's what that means. It means one's positive, one's negative. Now, on the assignment, do you need to write it this way or can you write it this first way? You can write it either. You can write it either way. It doesn't matter to me. Okay. So on that assignment, you got to realize then, hey, when I give you a question like the absolute value of X, you have to remember there's 2 possible answers. Okay. Now, what if I gave you something like this? Let me do another one here. X minus 2 equals, now let's try this one, 7. Let's try this one. Okay. So my absolute value, if you notice, it's X minus 2. So what is one of the possible answers that X could be?
5.
Sorry, what was that?
5?
Not 5. 5 minus 2 would give you 3, right? We got to get to 7.
Oh,
9.
9.
Okay, so 9 would be one of the answers, right? Because if we did the work over here, right? 9 minus 2 equals 7. The absolute value of 7 equals 7 and 7 equals 7. Yeah, that one works. But there's also another one.
Or
Somebody
negative
wanna- Sorry, what was that?
-5.
Okay, so you're saying -5. Okay, so some of you are looking at that. Sorry, that little symbol there is just an and. I'm lazy of writing and. So you say -5. Well, let's test it out and see if that actually works. So let's do this over here. -5 minus 2 equals 7. So this is where you got to go back and you got to remember your rules for subtraction, right? And this is what I was talking about before. Oops, let me move my page. Let me try to move my page up here. Right, this is what I was talking about before. When you subtract something, it's the same as adding the opposite. You guys ever seen that before? What I just wrote?
Yeah.
Yeah, you learned that back in middle years, but you're gonna have to teach that, by the way, too. It's called adding the opposite. When you subtract something, it's the same as adding the opposite sign on it. Well, if we do this, -5 plus -2 is -7. Yeah. And what's the absolute value of -7?
7.
7. So that one also works. Okay. So when you're doing those ones, you have to realize, hey, especially with absolute value, there could be more than one answer. So I think there was a couple questions on the assignment that talk about that. So make sure if you think you have an answer, make sure you plug it in and try it to see if it works. Okay. Is that a little clearer now for those that were asking about absolute value?
Yeah.
Okay. What do I need to do? I need to stop sharing that and put this back up. No, that's not what I wanted. Sorry. Get the right screen up first. Share screen and share. Okay. So you can go back here. I mean, these absolute values that we did on the board there now are just simple ones, right? But you can do them with formulas or, well, any equations. Okay. Now, something I'm going to show you next is these colored counters. And after we're done the lesson today, right, and after we do a bit of work on the stuff, the closing activity is using these, and I got a website for this, using these colored counters to teach about adding positives, adding negatives, subtracting positives, subtracting negatives, multiplying positives, multiplying negatives, and division, which doesn't really work for division because, well, you'll find out when we get there. But for the main ones, if you're teaching kids how to add and subtract with positives and negatives, this method with the circles works really well. Okay, so let's take a look at this first one. So, what we can do. So what we have is when we have a pair of oppositely colored counters, and here's the thing, the ones I'm using are red and black. In your classroom, you might have the red and yellow ones that are, red on one side, yellow on the other. You might have bingo chips. I got a stack of colored chips at the back. This works for anything, as long as you have two colors. So what it is here is, if you look at this first circle. If you count these ones, so I got 5 black ones. And then over here, I have more than 5 black ones, but I have these red ones, and these red ones counteract as negative. So you have one that's positive, one that's negative, and you can determine which one's positive and negative. So what happens is, for instance, this negative here and this positive here, they counteract each other. They're there, but we don't need them. They're 0. So then we have another one. So we take a red and a black, and we take those out, and we have a 0 there. So if you look, we still end up with 5, right? So you can use these to represent numbers of anything. So for instance, I could put another red and black in here. It would still be 5. I could put another red and black in here, and it would still be 5. Okay. So look at this bottom one here. I got 2 red ones. So that would be -2. And if you look here, every red and black, this red and black here, red and black here, red and black here, are all zeros. They don't count. They happen to be there, but they neutralize each other. So then we still have two reds, which is -2. So you'll see, we'll get into this in the activity. This is a really good way when you're adding, subtracting, multiplying, dividing to show how positive and negatives work. Now, here's the deal. We can represent zeros many, 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 many different ways. Because if you look at that, you got a red and a black. Do they neutralize each other? Yeah, they're gone. So we have a 0. This one, we have 4 sets of red and black. Do they all neutralize each other? Yeah, they're all zeros. And last one, if we didn't put anything in the circle, is it still a 0? Yeah, it is. Okay, so here's what you got to do. There's 4 of them on the screen. And if you printed this off, you really can't tell from the printing because you can't tell red and black on a black and white page. Like when I look at this, I can't see the colors on mine at all, right? I have to look at the screen. So here's what I want you to do. Determine what the numbers are for A, B, C, and D. So look at the numbers and determine what the numbers are, what they physically represent.
Can
I
I
should-
say A?
Sorry, what's A?
Yes,
What is it?
5 take with 2.
No, I don't want you. I don't want you to create a subtraction sentence. I want you just to tell me the 1-digit number that represents. So for instance, let me give you a little, this red and black at the top, gone. This red and black underneath it, gone. So how many black ones do we have?
3.
So that represents +3. That's what I'm asking. I don't want you to like do the 5 subtract 2, right? I want you just to look at what happens when you do that. Okay. So that first one represents 3. The second one, or sorry, B. What does the second one represent?
2.
2, correct? Because the red and black here wipe each other out. What about C?
0.
0, right? Because they all, right, eliminate each other. And D, the last one?
3.
Negative. Sorry, positive or negative?
Negative.
Negative, because it's red, right? Negative. And it doesn't matter which color you pick. It's just whatever color you have in your classroom. Okay. Sorry, go ahead.
What's B again?
B was 2.
Yeah. 2. Oh, okay.
Right? Because the red and black, whatever red and black you pick, like I picked the ones on the right-hand side here, those ones eliminate each other. And so you're left with 2 black ones, which is +2. Okay. And like I said, don't stress about this because we're going to do this as an activity at the end. And you'll find it's really a cool way to describe. Nice, Justin. It's really a cool way to describe it. All right. So, so here's the answers: 3, 2, 0. Okay, negative. Okay. Now, for every integer, there is an opposite. Right? Right? For if you're good, the opposite is bad. If you're not tall, you're short. Well, this is the same thing in numbers. Everything has an opposite. And we often call it, right, the opposite, or it's negative in this case. So what you can look here is, and this is what I was talking about when we were doing the absolute value. If you had a number 7, it has an opposite, which is -7. And when you add those together, you always get 0. But that applies both ways. So for instance, if you had a -7, the opposite of that is +7, and you still add them together and still get 0. That doesn't change, right? So everything has an opposite, which is actually, if you think about it, that's the whole basis of algebra, isn't it? Right? If you're multiplying by something, you do the opposite, which is divide. If you're adding something, you do the opposite, which is subtract. So this is a really common concept. Justin, I think you have an intruder in the room. Okay, so if we look here, I have 5. Now, if you look, the big circle represents the whole thing. So within here, I have +5, the 5 black ones. In here, I have 5 red ones, which is the negatives. And those are opposites of each other. So if we put them into one thing, all the red and blacks neutralize each other, and we end up with 0. And that works for any number, right? It's opposite. Okay, sometimes referred to the negative. So here we go. I think this one just pops up. Oh, it already does. So we got 4. What's the opposite of 4? -4. You can see it on the screen. What's the opposite of -2?
2.
+2. Hey, what's the opposite of 0? It's 0, right? Remember, 0 has no negative or positive. And what's the opposite of -320? +320, right? Okay, now another way to represent integers, especially with zeros, is on the number line. Remember, I think we did this last week. This kind of looks weird when they do this with the zeros because we already covered the ones with the zeros. So if you look at this one, the first one here is 9, right? We start at 0. We put our line up to here. Hey, so there's our 9, and then we add 0 to it. Remember, zeros just look like loops because they don't go anywhere, right? 0 is just back up and down. So that equals 9, which is just this one here. Okay. Now look at this one, positive 6, and then we add negative 6 to it. So do we end up back at the beginning again? Yeah, and that's the same as 0, right? That's just showing on a number line how that works. I don't know, like I think we said this, like I told you last week, some of you will have number lines in your classroom. Use them. They're really good visuals. Most people will have them on the, the outside of their classroom, the outside walls of their classroom, right up near the ceiling someplace. They're really, really useful. Okay.
I remember them as a kid.
Sorry, what was that?
I really remember them as a kid.
Yeah. And it's good to see that visual representation. And the nice thing about the number lines you can get nowadays is they do all the positives like up to 100, but they also give you a lot of the negatives now too, right? They'll go to the left of 0 and give you a bunch of negatives. Okay, so what we're going to do is we are going to now do some addition and subtraction. Ooh, I know you're so excited. Ooh, we get to add. But remember, you're going to be showing people how to add, so that's why this is important. Okay, so the addition and subtraction of integers. So here's my screen screwed up again. Oh my goodness. Here is the thing. If you add A and B, the new number is defined as a union, right? That's what this funny thing is, a union of A and B. So you have 7, you have 2, you add them together, it's a union. Okay, that's the technical stuff. That's in the back of your mind. You're not going to teach that to the kids. That's for your knowledge. Okay, the visual representation is a great way for doing this. So take a look at this. So in our big circle here, we have positive 8, correct? In our smaller one, we have negative 3, and we want to add those together. And kids really struggle with this concept because what do? I go forward on the 8 and backwards on the 3, like if they were doing a number line? Well, look at it this way. You know already, as soon as you have a red one and a black one together, are they gone? Yeah, they eliminate each other, right? That's a 0. So what you do here is every one of these 3 red ones, I can take out 3 black ones. And then what I'm left with is going to be the answer, right? So 8 plus negative 3, and if you take those out, you're left with 1, 2, 3, 4. Oh, I'm left with 5 black ones. So positive 5. So there you go. There's a visual representation with that. And when we do this later, like after the lesson and the activity, or for the final activity, you're going to actually do this on a virtual page, and you're going to grab pairs of them and drag them off. So then you can really see them. If you had these with kids, you could actually, the kids could pick up the red and the black, put them together, set them down over here. Pick up a red and a black, set them down and see what they're left with. Okay. And like I said, we're going to do this activity. Okay, so let's do on here. So let's talk about M and N are positive and M and N are negative. So there's some rules here. Here's one of them. If you have 2 negative numbers and you add them together, it's the same as adding the positives together and then just throwing the negative in front, right? If you don't believe me, think about it. Negative 7 plus negative 5 is the same as negative in front, 7 plus 5, which is 12, and then make it negative, right? It's just another way to look at it. Okay. If the first number is larger than the second number, so let's say M is greater than N, right? That's what that means. Remember, the alligator's eating the bigger number. Then M, you could do M plus negative N, or in other words, you could subtract. And this is what I was talking about with the additive inverse rule, right? If you have M minus N, this last part, it's exactly the same as M plus the opposite of it, right? So instead of subtracting, we could say we're adding the opposite, and the opposite of N is negative N. Okay. These rules are just a different way to look at adding and subtracting. Really, probably when you're going to teach us, you're going to teach it with manipulatives, or you'll see once we compute the next slide, you'll see right away. Here's another one. Okay, so now if the first number is less than the second number, so for instance, if it's negative or smaller, then what you do is you add them like this, the m plus the negative n, or the other way to do it, and you can see is n minus m, and then make them negative. Okay, it's just, I don't know if you ever learned, do any of you remember learning it this way for adding positive and negative numbers? Did you ever learn these algorithms, or did your teacher do it on a number line? Anybody?
I can remember doing it like you're doing here.
With the thing, and I think Olivia, is that an X you put up there because that's not the way you learned it? How did you learn it? Was it with number line, Olivia? Do you remember?
I think I learned in both ways.
You learn it's a tough one. It really depends on the teacher you had, whether they have an understanding of it or not. A lot of people nowadays will use manipulatives, and that's what the common way to do it is, until you remember the rules, right? And then the last one is, if you have two numbers, and we know this already, if you have a 7 and a -7, doesn't matter, it's -7 plus 7, you still end up with a 0, right? So when we get down to it, so let's look at the next page here, and I think I got 5 of them here. Oh, and of course, I don't know why because I'm using my master list here, that's why. Oh, there it is, Olivia, number line. Sorry, thanks, Olivia. So for instance, hey, if they're both positives, yeah, can you just add them together? Yeah. Now, here's the thing that everybody gets mixed up, and you'll get this when you teach it, and some of you might get this mixed up now. Don't mistake the rules for addition and subtraction as the same rules for multiplication and division. That's super common. So for instance, look at the next one. -6 plus -5. Some people think, oh yeah, they're two negatives, I get a positive. No. That's only when you multiply them. Remember that rule? Two negatives multiplied give you a positive. So look what we do in this case. And you could do it either way. You could just say to the kids, okay, -6 plus -5, since they're the same, we just add them together, we get our -11. Or the other way to write the rule is, right, because they're both negative, you could add the positives together and then just make the whole thing negative, right? So it'd be just 6 plus 5 gives you 11, and then the negative out the front just makes it negative. You could teach it either way, just as straight addition, like the first part, or the second part with the rule. Doesn't matter. Okay. C, 7 plus -3. Some kids will look at that and they'll go, that doesn't make any sense to me. But remember what we said, additive inverse rule, right? You can add the opposite. Well, we can go back the other way. Since we added a negative, it's the same as just subtracting, right? That was one of the rules on the, oops, let me back up here. That was the rule on the previous page here, right? You're just subtracting right here. Okay. So in this case, 7 plus -3 is exactly the same as 7 minus 3. Oh, that's way easier. I have 7, I take away 3, I end up with 4, right? You have to decide when you're teaching and when you're dealing with the kids, which one you're going to pick. Oops, sorry, I just went by it. This next one, 4 plus -9. Okay, now this is a weird one. This is one of the algorithms from the previous page. 4 plus -9 is the same as taking the 9, subtracting the 4, right, which is 5, and then putting the negative out the front, right there. To me, honestly, I don't like that method, but that's just one of the algorithms. You might have learned it that way. I might have learned it that way at one time. I don't honestly remember. I would prefer to 4 plus -9. I would do it as a number line, right? Go +4 and then go back -9. I would like that method better. That's just me. And then the last one, 6 plus -6, that was the last rule. Anything plus its opposite is 0. Okay. So those are just different ways to explain addition for adding integers. Okay. Now, there is some rules. These rules that I'm going to show you, or sorry, I shouldn't say rules, I say properties. You know these properties already. We learned them last week. We are going to keep learning them again and again and again, but they're just in different situations. So for instance, let's look at this first one here. If we have, okay, here we go. The closure property. If you have an integer and you add another integer, what do you get as a result?
An integer.
There we go. That's the closure property. If you remember that from last time when we did that with whole numbers, right? A whole number plus a whole number you end up with a whole number. That's the closure property. Okay. Next property, commutative property. If you add two things together, it's the same as adding them together the opposite way, right? So for instance, if you had -7 plus -2, it's the same as -2 plus -7. That's a commutative property. We did that before for last week, but that was for whole numbers. Now we're doing it for integers. Now, by the way, do you think that applies to all the stuff we're going to do coming up in the next few weeks? Yeah, all these properties apply. Then we have the associative property. If you have n and then n and r in brackets, it's the same as putting the brackets in a different spot. That was the associative property. And again, this applies for positive and negatives. It makes no difference. Okay. So those three properties you've seen before, they're not going away. Okay, then we have the additive identity property of 0, which means you take any integer and add 0 to it, you get the integer. So -1 million plus 0 is -1 million. Makes no difference. If you add 0 to it, you end up with it. But that's the fancy term for it, additive identity. And the existence of negatives. We talked about this. Any number has an opposite, and if you add them together, you get 0, right? 7 plus -7 is 0, or -7 plus 7 is 0. Where are we here? Oh yeah, we're still doing subtraction. Okay, okay. So now that was addition. What time is it? 6 o'clock. We're doing fine. We can look at number line. So another way to look at addition of stuff is on the number line. This might be the way you learned it at one time. I'm not sure. Okay. Oh, come on. There we go. Here is the old number line. Remember doing this? Some of you might have hated this at the time, but it's the way it is. Number line is 5 plus 4. You start at 0, you move up 5, and then you add up 4. Note the tail of the 4 is attached to the arrowhead of the 5. That's the standard way when you're dealing with positive numbers here. So you go 5 plus 4, and you end up with 9. Standard way of doing it. Oh, sorry, go ahead. Oh, sorry, I thought somebody had to say something. Standard way of doing it. Okay, now, what do we do when there's negatives? Well, here we go here. 5 plus -4. So you notice the tail of the -4 is attached to the arrowhead of the 5. So we basically go forward 5, and then we come back -4. And where we end up, positive 1, there's our answer, right? So you think about this. If you're teaching kids how to add 5 plus like a positive and a negative, you could show them with the black and red discs, and you can also show them with the number line. There is lots of ways to do this, and every kid is different. Okay. So let me give you this next one here. So take a minute, and I want you right beside those ones to add, to put what you're doing. So for instance, are you adding this? They're all addition, but put the addition and then put the answer. Grab something. Okay. So do those 3 beside you. I'll be right back. Sorry about that. I just realized that since there's no kids here today, the cleaners that clean our school are done early. And I had to go sign in so they don't set the alarm on me. I don't know if any of you ever had the alarm go off at a school. It's not very nice. Yeah, they normally stay till 10 o'clock, but I think they're all done now because very few kids in the school today are no kids. I have to remember, I'm gonna have to write myself a note to remember that tomorrow. And from now on, I better sign in. Give me 1 second. Let me just write that down. Sign in for alarm. There we go. Okay. So anybody get the first one?
Yep.
What'd you get?
0 plus -3 equals -3, and then plus +5 equals +2.
Okay. So yeah, so -3, yeah. So 0 to -3 is your -3, and then +5 gives us our +2. Excellent. Anybody on the next one?
-2 plus -4,
Yep, and that equals -6.
-6.
Good. So you can see with the number line, it actually works really well. And like I said, you can do this, and we'll do it later with the discs. It's kind of a useful way of doing it. What about the next one?
5 plus -7 is equal to -2.
Correct. Thank you. Thank you. I think that was Nadine that said that. And the last one, last one's tricky. Not really, but go ahead.
0.
What do you got?
-4 plus 4,
Equals
0.
Now you could have had that other way, depending on which color you did first, right? Because you could have done the blue, or you could have done the red. It's not a big deal. Yeah, perfect. So those are visual representations on a number line, adding integers, which is kind of cool. Okay, now let's talk about. Oh, sorry. Go ahead.
I struggle to understand like the properties. Like I get them, but I mean, it doesn't make sense for me to memorize them. But you had multiple questions about this on the exam or on the test we did. So I just was wondering if we could like review which properties those would be.
Okay. Oh, let's back up again. So the properties we're talking about here. Let's back up. Closure property is if you take any numbers. So let's say they said, okay, you had two numbers, two integers. The closure property is if you add them together, you always end up with an integer, no matter what.
I understand them.
Oh,
but
sorry.
I struggle with identifying them when you put them in the questions. I
Oh,
where I'm at.
okay,
So I'm
okay.
wondering if we could kind of go over that, because to me, I'm like, well, I just know the answer. I don't know the property. So it's just like, it confuses me a bit.
Okay, I got you. Okay, so let's
Yeah.
hang on. I can't remember if we cover it later on. No, let's do it now. Okay, give me 1 sec. Let me stop this. Where's my?
Because I actually thought you were asking us to identify the property in those questions, and I was like, I have no idea.
Okay, yeah, no problem. Let me stop sharing this. Give me a sec. Thank you for
Thank you.
asking. Because if you asked, then probably somebody else was going to ask. Throw that up. We'll throw that up. Share screen. That one. Share. Here we go. Oh, where's my marker? Oh, there it is. So if I said, let me think of a question here. I'm just trying to think off the top of my head. Oh, so let's say I gave you on a test 7 plus 2 plus 5 plus, and I'm making this up. I'm just making up something really big like this. So let's say I said that, and I said 5 plus -2 plus 7 plus 2. Let's say I asked you something like that, and I said, okay, what property does that represent? Which one do you think that would be in this case?
Commutative?
Commutative, yes, because it doesn't matter the order that you put stuff in. All right, and it could be anything, like, because we can get in, for instance, eventually we're going to get to the properties where you get like something like x plus m plus 2 equals the same as 2 plus x plus m, right? And it can be with variables. It doesn't make any difference. That's still the commutative property. Okay. Associative is anytime you see something with brackets. So if I gave you -2 plus 7 plus 5, and I said something like this, oh, good grief, -2 plus 7 plus 5, right? Right, and that would be associative property because it doesn't matter where those brackets are. Sorry, that's supposed to be a plus 5. Wow, that's a horrible plus 5. The other one we haven't we covered last week, which we're going to come up to again, is the this one here, 5 plus 2 plus 7, like this. This is coming up. We haven't covered this. Well, we covered a bit of it yet, and I put 10 plus 35. Right? Do you remember that property? It's
Distributive.
yeah, distributive property. Those are the three big ones that you're going to have to remember, right? Commutative, associative, distributive. And if you want to acronym, just think of CAD, C-A-D. Commutative, associative, distributive. Okay. Commutative, the order doesn't matter. Associative has brackets. Distributive is putting everything within the other stuff. Is that a little clearer for examples?
Yeah, I think maybe I'm just lost on this because the subtraction ones had a whole bunch of them too.
Yeah.
And
Keep
I
talking.
think that question just didn't make sense to me. And so I struggled with that.
Okay, so here's the deal. So on a test like that, if it's really unclear, just ask me. I was helpful to some people, like trying to clarify stuff. So
Yeah, you were.
okay, no. But I never want you to feel like, oh crap, he didn't ask that question ever. So just ask that question, and I will try to clarify it as best I can even on the test. So
Okay. Thank you.
you're welcome. What am I doing? Oh, stop share. Sorry. Back up here. Give me 1 second, guys. Let me just get everything back. Share. There we go. Okay. Where did we get to? So we did these ones. We did those. Did all those. Okay. Let's talk about the old greater than, less than. Okay. This is, and if you remember, it's the smaller number eats the bigger number. I don't know how you learned it at one time. You can teach, or Pac-Man. Some people I think learned it as Pac-Man. Some people learned it as the arrow points to the smaller number. I don't know if you ever learned it that way. There's a whole stack of ways of doing this. So what I want you to do is I want you to put the symbols. Well, I guess you can't really pretend on your screen which way the symbols go. So which one's larger, 17 or 121?
121.
So is it eating the 121?
Yep.
Yeah. So when you do that, you would say, now you got to be careful how you say this too. You got to get the terminology down. 17 is less than 121, right? Because that's what it is. It's less than 121. Oh, somebody has a chat there. Who's that? Sam, the crocodile method. Yeah, that's crocodile. Yeah. Crocodile, Pac-Man. There's a whole stack of ones. Okay. What about the 2 and the -7? Which one? Now, here's the thing. Which one is smaller?
-7.
Now, when you're teaching kids this, which one will they think is the smaller number?
2.
2. Oh, 2 is way smaller than 7. But then you have to teach them on a number line. The farther you go left from 0, the smaller the numbers get, right? Like -7 is small, but -127 is way smaller, right? So you have to talk about that. So in this case, the 2 is the larger one. So you would, sorry, I got to get back into my screen again. 2 is greater than -7. Okay. What do we got? C, -7 and -27. Which one's the smaller one?
-7.
No. Remember, the farther you get from 0 going left, the smaller the number. So go ahead. Somebody else was going to say it.
I said -27.
Yeah, the -27. So if you look at a number line, the -27 is farther to the left. It's a smaller number than -7 because it's farther away from the 0 on the negative side, right? So then you would say -7 is greater than -27. 0 and -6, which is the bigger number?
0.
0. So we go 0 is greater than -6. Good. Now you can also, oh, sorry, that was all ordering pairs and answers. Okay, so what we got left just before, what do we got left? 1, 2, 3, 4. We got 5 more slides, and then we'll take, then we'll do some activity. We'll do some work here. That was all addition. Let's talk about subtraction. Okay. Now, this is where it gets a little trickier, and we'll do this activity at the end of it because you want 7 and I want to take away -3. Well, the problem is if you look here, I have way more than 7 black ones. 1, 2, 3, 4, 5, 6, 7, 8, 9. What's going on here? That doesn't make any sense. So what it is, and when we do this activity at the end, it'll make sense because I'm going to get you to go step by step. So we must take away a representation of -3. Since the representation of -3, we have to have at least 3 red counters, right? But what happens is we need to be able to have the same number in black, right? So you have your 7 here, but we need the 3 extra ones to match the -3. And if this doesn't make sense right now, don't stress. We're going to do it at the end physically. I'm going to go through step by step how to do a subtraction, and it'll make more sense. So what we physically do is take away 3 of those, bang, and we end up with our 10 of positive. Okay. So you're thinking, well, why did we start with 10 black one? Well, because we need 3 of the black ones to match the 3 of the red ones. And like I said, once we get to the end, it'll make more sense. Like in, what time is it? 6, in about an hour. In about an hour, it'll make way more sense. I know some of you hate that when I say we're going to do it later on, but you got to be patient with me. There is a method to my madness. Okay, so if A and B are integers, A minus B equals C. Therefore, the rule is A equals B plus C. What are you talking about? Well, here, give me a number. 10 minus 7 equals 3. So then 10 equals 3 plus 7. Oh, yeah, that does work, right? Makes sense, right? Whatever you subtract is the same as adding. So what happens is a lot of times when you're teaching subtraction, you can teach the adding method because that's basically what it is, right? You're adding, but just in a different direction. So here's the other one. A minus B is the same as A plus negative B. That is the good old adding the opposite method. So 10 minus 7 is the same as 10 plus negative 7. Makes no difference. 10 minus 7. Well, here's the example. 5 minus 2 is exactly the same as 5 plus negative 2, right? And you'll find this one, adding the opposite, is useful and it's not useful. And I'll explain it in a second. Okay. So let's do some examples here. So we got 7 minus 3. To me, that one's really easy to do. I just go 7, take away 3. So, and if you were to add the opposite, that's what it would look like, 7 plus negative 3. Well, that seems really silly to me to do that, just change it, yeah? Does that seem silly to you at all? Yeah, I would stick with the original method in this case. So you'll see sometimes adding the opposite is not always the best way to do it, okay? The next one, -7 minus -3, right? If you were to add the opposite, it would be -7 plus 3. I don't really like that either. -7 minus -3, I find it easier just to make my -4. Yeah, a negative, subtract another negative, there's my negative. Yeah, I don't know if I would do this additive inverse. Now, the next one though, watch this. 7 minus -3. I don't like that. I really don't like the way that's written. But if we add the opposite, it's exactly the same as 7 plus 3. Way nicer to work with, right? That one to me makes way more sense for doing the adding the opposite. And then the last one, -7 minus 3. If I were to do the adding the opposite, would be -7 plus -3. Yeah, I like that method again. So for A and B, for me, I don't like adding the opposite, but C and D works really well. And I think you'll find that with kids. B seems a lot, yes, B does seem a lot harder. You're right. But doing that in C and D, though, Sam, I think makes a lot more sense doing that additive inverse one because it just makes it clearer, right? See how we took the -7 minus 3 and changed it to this? Yeah, I like that much better. like I said, like in this course, right? I'm going to show you a lot of different concepts for math about, how to deal with addition and subtraction, how you're going to deal with it with kids. You kind of have to decide which method works for you and works for the kid. And you'll get that as you get years of teaching underneath you. Okay, now. Okay. So if you look on this first one, Sam, 7 minus 3 is just way easier just to subtract, right? So changing it to this additive inverse just seems silly, right? So in this method, I would just stick with the 7 minus 3. The second method, that one's easy too. -7 minus -3. I don't want to switch to the additive inverse rule because it's just easier to go -7 minus -3. That's just really quite simple. But this last one, a lot of kids are going to see, or sorry, see here, a lot of kids are going to see 7 minus -3. Whoa, I don't like that. But if you do the additive inverse, which is 7 plus the opposite, well, 7 plus 3, they've been doing since however many years after that, right? So there's going to be different methods that you use. Sometimes you'll use additive inverse and sometimes you won't. It just depends on the kid and the situation.
So for me, with B there, I don't know if this, I don't know if my comment makes sense with this, but it seems harder to do it with me with that first method, -7 minus -3, than it would be just -7 plus 3. So all you have to do is add forwards, right?
Yeah,
And
but
-4.
no, that's fine. And like I said, everybody's going to be different, right? If some people are going to like this first method and some people are going to like the second method, it's up to you. It's just explaining that you have the option of additive inverse, right? And like I think Callie said in the comments, that was really good. It gives us a lot of options when you're teaching this and or whether you're learning it, right? That's the key. When you have to teach this, you have to have a number of different options because kids are going to learn differently.
Don't you like the way I learned it is if you have those two negatives beside each other, they turn into a positive. Is that another way?
Like you're talking about?
Like I'm talking about -3, -3. Doesn't that turn into a positive?
Which A, B, C, or D? Which one are you talking about? Sorry.
B, when it says 7 minus, and then it says -3, doesn't that turn into a positive, like those two minus beside each other?
Yeah, well, this here, let me show you something. Give me 1 sec. I think I know what you're talking about. Give me 1 sec here. This is what I teach in high school, and I bet you this is the method you're talking about here. Hang on. Now you got me all excited about math. Like, oh, this is exciting. Sorry. You guys probably just shake your head when you hear me. What was it again? -7 minus -3? Yeah?
Yeah.
Tell me if this is the way you used to do it. This is the way I do it when I teach high school, especially what it is. Oh yeah, I see a subtract there. What I do is I add the opposite. Is that what you're talking about?
No, like say those two, I don't know, like those two negatives turn into a positive. I don't know. That's how just I was talking.
Which negative? Like this one here?
The one in the middle, then the one before the 3. So those two would make a positive.
Well, well, you're still subtracting, so you got to be careful with that. I would do it like that if you're going to change it to a positive because you're adding the opposite. But I hope if you're talking about multiplication, no, that's something different. But I'm not sure if that's what you're talking about. I might not be just clarifying. No, okay.
Are you talking about the like a negative and a negative equals a negative, a negative and a positive equals a positive?
Like that? Are you talking about?
No.
Okay.
Like if they're right
Wait.
beside each other, I don't know. I don't know where I learned that, but I got the answer the same as the way you switched it, but
Oh, okay.
not like that.
Okay. And if that's the way you learn, that's fine. There's nothing wrong with it.
I think she means like you take the second negative dash and then move it over to cross the first dash and turn it into a positive, because that's how I learned it.
Oh, did you? Yeah, you went to Massey. I mean, they don't do anything.
No, I didn't go to Massey.
Oh yeah, you went to Neil. That's right. Oh, that's even worse. Never mind. I'm just joking.
Don't you judge me.
My job to judge. I'm a teacher. That's why we're all becoming teachers. Well, hopefully. No, I know what you. Yeah, see, it just really depends on the teacher you had, right? So they're gonna have different methods.
But I'm changing my career.
Hello?
Hello, sorry. Who asked a question? Sorry, I missed that.
Like, like the way I was taught is to try get rid of the brackets first, like write it like -7, negative, and with the 3, then because a negative and a negative equals a positive. I think that's what she was talking about.
When you multiply them, not when you add them.
When you add them, a negative and a negative is a negative.
It's still a negative. Only when you see, that's the rules I was talking about. You'll see them when we get to the multiplication section. It's one of the
But
Okay.
this is adding, you can get rid of the brackets, right?
well,
Isn't that with bed mass? The
well, okay.
brackets?
The brackets are there. There's a reason.
Yeah.
Let me show you something. Again, what screen? Yeah, okay. Let me show you something. There's a reason we do brackets around negatives all the time, because what happens is you start to get stuff that looks really, really weird. So for instance, if I wrote this, that looks weird, doesn't it? So
The
often
brackets.
what we'll do is
But
when,
isn't
sorry, go ahead.
but isn't that when, like, because we were taught that when there's 2 negatives together, that becomes a positive.
Yeah, that's
Isn't
it.
that what
That's what I
we were-
meant, like, if-
Well, that's what I was talking about. So for instance, look here. So if I put brackets around this, that just breaks it up and shows it. So my 2 negatives are together. It's the same as adding the opposite, which is changing it into positives. We're talking about the same thing. It's just how we interpret the way it's written, or how we interpret how you do it, right?
Okay, well, it make a difference if you put minus and minus in front of -7.
Sorry, say that again.
Well, it make a difference if you put a minus in front of 7.
Okay, well, if you're doing this, but we're going to get to that. That's the next rules. If you want to wait 1 second, right? So for instance, whatever this happens to be, right? When you have a negative in front of it like this, because there's no addition or subtraction and we have the brackets, that's multiplication, right? So a negative times a negative is a positive, right? I'll put the positive in there, but you don't need the positive. That's the rules for multiplication, right? Which we're going to do after we do some of these questions. If you look at the slides, right after 5 points, the first thing in 5.3 is a positive times a negative times a positive, and 2 negatives times each other. Those are the, here. Well, here, give me 1 second. I'll show you what's coming up. Hang on, let me back up here. PowerPoint. Need this one. Give me 1 sec. Sorry. I was gotta remember to share the screen here. So if you look right here, these are the rules you're talking about here, right? Right, positive times, and this is coming up. But I just wanted to make sure you're clear on that. That is coming up. Don't worry.
I'm still talking about subtraction.
Well, when I did that on the board with the negative in front of the -7, it's still a negative times a negative because it's the symbol in front of it.
So the symbol doesn't change, the negative.
Well, it depends if it's like the one I had up was negative in front of the -7 turns into a positive because it's -1 times -7. We'll talk about that in a minute. But for now, I want you to let me just finish the one thing here with the number line. And then I'm going to give you some practice because this will make more sense as we do it with the practice. Okay. Hang on 1 sec here. Need that. And there we go. So this is a little trickier when you're showing subtraction of integers using a number line, because if you look, the tails are different. Sorry, the heads are different and the tails are different. So if we have 5 minus 3, you would, okay, you draw your 5 in from 0 to 5, but when you subtract the 3, the 2 heads have to be together, and then you come back 3, and where it starts is where you end up with. So in this case, if you look at the 3, right, the 3 is here, that's where it has to end. So we go the 3 this way, and we end up with our 2. It seems like kind of a very backwards way of doing it when you're talking about number lines, right? Like addition, when we did addition, it worked no problem when we were dealing with negatives because you just switch the direction. This one, you have to keep the direction of the tails and the heads the same way. It's just the way you teach it, and it's a tougher way to do it. You might find a simpler way, but that's the way that it normally is. Okay, so what I want you to do, what time is it? Crap, we're running out of time. Okay, let's get, I'm just figuring out time here. 10 minutes, 10 minutes of work. We still have 5.3 to do. Crap, oh, 5.3 is pretty short. Okay, so you want to take a break now, or do you want to do some questions? Here, oh, sorry, Lori has a question, I think. Lori, you have a question? Your hand's up. That's why I was just asking. Okay. Show me by, here, let me ask the question and you can respond. Oh, Sam wants, okay. If you want to break now, put a thumbs up.
Break. No.
If you want to do some questions, what's the other symbols you can do? Can you do an X? Can you do X's? I can't even know. I don't even know. Tanika, I like that one. What is that? Is that like it's like a party. Okay, if you want to do some questions first, put up another symbol. I don't care what it is. Just don't put a thumbs up. 1, 2. Hang on. Callie, I like that one. It's like hearts, X's. Oh, guys, you guys are split. Okay. Okay, here's the deal. For the next 20 minutes is break and questions. You decide when you want to do it. If you want to take your break now, go 10 minutes, come back, do questions. If you want to do questions, stay now and then take your break in a little bit, okay? I'm leaving it up to you. But we'll do that for about 20 minutes or so, okay? So if you want to break, go for a break for 10 minutes and come back and we're going to do, sorry, I went by it. We're going to do these questions here. Okay. Either do the questions, then take a break, or take a break and do the questions. It's the same amount of time for me anyways, it doesn't matter. And then we'll do multiplication.
I have a question.
Yes.
In the assignment, question 6, you say find the absolute value of the quantity. Do you want the positive and the negative?
Are you talking about the assignment, sorry?
Yes,
Which question?
question 6.
Question 6? Yeah, so the what they give you is 9 subtract 20. So do that first.
I
Okay,
did.
don't tell me what you get. Then you get your answer. Then I want you to take the absolute value of it. Right? That's all it is. So the only difference in this case is they did not put those. I did not put the up and down lines around the 9 minus 20. I'm just telling you to find the absolute value. But the other way to do it is put the vertical lines around the 9 and the 20. If you want to do it. Either way, do the math first, then find the absolute value.
Are you talking about brackets? Oh,
Right now it's 9 minus 20. And what I'm asking you is to find the absolute value of that answer. The other way it could have been written is vertical line, like the bracket, vertical line, 9 minus 20, another vertical line. It's the same way as saying it in words as it is mathematically. Here, let me put it up on the board here.
yes, I don't know what the vertical line means.
Give me 1 sec here. Hang on. Stop sharing. I always got to remember to share screen. I want this one, share. Ugh. There's 2 ways of writing this. I'll show you both. The first way is find the absolute value. Right? And it would be like this, 9 minus 20. So you do the work, find the absolute value. The mathematical way to do it, if I asked you, is this. They mean exactly the same thing. One is in words, one is mathematical. They will still give you the same answer. That's what I'm asking you to find.
Okay,
Does that make sense?
I'm not sure, but I'll just do it. I still don't know what the lines mean. Is
Brian,
it
when are we breaking till?
Quarter to. About that.
Okay.
Well, we're not really breaking. You can either take a 10-minute break and then do 10 minutes of exercises, or 10 minutes of exercises now and then take a break. Or if you really want, hey, just do all exercises, but don't do all break. We don't like that.
I have a question kind of similar to Alice's, but it's for question 9 on the assignment.
Hang on, Lacey.
No
So I just gotta
problem.
get number 9. Where's 9? Okay, go ahead.
Well, I mean, it's kind of infinity because you could just keep changing the numbers and end up with 3, whether it was a negative or a positive. So how many pairs do you want us to use? Like I could go as high as like negative 97 minus 94. Like, you know what I mean?
Well, no, you can't. Because it's the absolute values added together. Right?
But based off what you just said, the absolute values are positive or negative. So
No,
like that's
but
the thing
okay,
that I'm
but
getting lost on these equations because
no, but you ignore for right now, ignore the absolute values. If you just had x and y has to equal 3, you could have 0 and 3 or 3 and 0
yeah,
or 1 and 2 or 2 and 1.
yeah.
I think that's it. Now, if we have the absolute values, you still have to take the absolute value of the number and then add it to the absolute value of another number. So for instance, what did you say? You said what, like,
Well, for one example I have is like x is 0 and y is negative 3 because the absolute value of y is 3 then. So then it's 0 plus 3 is 3.
perfect. But there's not an infinite number of values. There's only, there's a limited number of values.
I have 6 sets already.
Yeah, I think there's, hang on, let me count here. There's 12 in total, 12 values, 12 sets, sorry, 12 sets. So if you get, I'll just say on that one, if you get 6, then you'll get the full mark. If you get all 12, big deal. It's the same as getting 6.
Okay.
But some of the big ones, like the absolute value of negative 97 or 97 will not work because you need to add it to something else just to get 3. So that all the numbers have to be under 3. 3 is the max any of those numbers could be.
Okay. And then are we going to be going over like the absolute values with the negatives on the outside and with the brackets on the inside at any point?
Like which is there, did I give you a question like that?
23 and 25.
Hang on. Let me turn to it. 23. 23. Hang on. I just went by it.
No problem.
Okay, so 23, here's the deal.
Yeah, 23, 25, and 29 are all kind of like I've starred them because I'm not really clear on how to go.
Okay, well, 23 is exactly like I have on the board right now. Right? It doesn't matter what you do. For instance, 9 minus 20, I'm going to get a number. But when I take the absolute value of it, you can do that. So do all your work in the center. So on 23, do all the work in the center, right? The negative 11 plus the negative 17. And then whatever answer you get, take the absolute value of it.
Okay.
What was the other one?
25, because the negatives are outside, but there's a
Okay,
negative on
so
the
here's the
inside.
deal. So 10, the absolute value of 10 is 10, but that negative is on the outside. So that 10 now becomes,
Has to be negative 10 now.
right, negative 10. And the same with the absolute value of negative 8 is
8. So it
8,
has
and then
to be-
it's minus 8, right? Because that doesn't change.
Oh, so I actually did get that right then originally.
And same with 29 when you get to it, right? Basically do the absolute values first. They're
Okay.
going to change the values and then deal with your signs outside of it.
Okay.
You could almost
Okay.
you could almost treat them, well, technically the absolute value signs are like brackets, but the only difference is these brackets make everything positive. That's the only difference.
Right. Okay.
Does that make
think
more
that
sense?
helps. A little bit, yeah.
Yeah.
Yeah, thank you.
You're welcome.
Does absolute value mean if if it's the answer is 7, the absolute value is minus 7.
Sorry, say that one more time.
Does absolute value mean if the answer is 7, and it could also be minus 7?
No, no.
How to
The
do it.
absolute value of 7 is 7. It's the distance from 0.
So the absolute value will always be positive.
You got to be careful with that one because it's the general one, right? The absolute value will always be positive, except what if I put a negative in front of that absolute value? Well, then the answer is going to be negative, right?
Yeah.
Yeah, but you're right. The absolute value normally when you do everything is always a negative. Sorry, is always a positive because it's the distance from 0. But like you'll see, I think which question was it? There was a negative in front of one of them.
25.
25. Yeah. So that positive 10, absolute value of it is 10, but then because the negative's in front, it becomes negative 10. So the absolute value part is always positive, but then the answer could change to a negative. It's just like
But
algebra.
the negative 8 doesn't change.
Sorry, what was that?
But the negative 8 doesn't change.
No. Okay, what's the absolute value of negative 8?
8.
8, but then that subtract out front means minus 8. I see what you say by not changing, but you actually have to do the math too, right? You have to change the negative 8 to a positive 8 and then do a subtract from it, or subtract it, sorry. Oh yeah, sorry, I was doing attendance because somebody just messaged me. Who was that? I think was it Brooke? That's not what I want.
Yeah, it was me.
Oh, it was
Brooke.
Brooke. There we are. Okay, yeah, let me fix that now. Where are you? Brooke, there you are. Oh yeah, who was the other two that I was missing? Maybe they showed up yet. Did Heather show up? Heather Burns? Heather, are you here? I can't see. Let me look. No, I don't see. And the other one was Kayla George. Is Kayla here? Let me look. There she is. Okay, there's Kayla.
Yeah, I signed in late.
Oh, that's okay. No, I had done attendance already, so I just wanted to make sure you got credit for being here. So there you are. Now that's fixed. So I think the only one who's missing is Heather, I think. Let me just double check. I never want to miss people if they've signed in. Yeah, that's the only one. Okay. What time is it? Oh, we're still. Crap, we're running out of time.
I felt everything was clear, but all the brackets and negatives and subtraction and addition is confusing me, but I'm sure doing the practice exercise will help.
It's a matter. I mean, if you haven't done it in a while, then I mean, you have to try to remember it has to come back to you. Like when we talk about the multiplication and division, I mean, there's multiple ways of showing how to teach it, but there's one way to you just have to memorize the rules. And that's the first thing we do right in multiplication. I'm just going to give you the rules right away. Oh. time in the break there. I'm just gonna fill up my water bottle. I'll be right back. Need more water. Talking too much.
I have a question for.
Yep.
Question 12 in the textbook on page 230.
230, question 12.
Yes,
Okay. So what's the absolute value of 34?
34.
What's the absolute value of 0?
0.
What's the absolute value of negative 76?
Negative 76.
No. How far away is it from 0?
76.
76. What's the absolute value of negative 12?
12.
Perfect. There you go.
I think I'm getting it.
Hey, Brian, these practice questions, I have a question about them. Are you marking them like, or are they just for practice sake?
They are practice questions. No marking. They're just for you to do. That's so cool, Justin. I can read what's on your phone as you're texting. I'm joking. I can't. I can't, by the way. He turns off the camera. By the way, I can't see that. Don't ever. I was just trying to see if I could freak you out.
I forgot I had the camera on because I was just doing some prep in there.
That's no worries. I'm not giving you the gears.
Yeah, it was just a hectic day today.
It was hectic here at school for some people, but not for others. I mean, for me, it was fine because I was prepared, but some teachers were just they're not good with technology. I mean,
yeah.
You can see there's days I'm not good with technology, but I'm trying to run. It's hard. It is really hard to run a classroom just full technology. It's just ridiculous.
I have a question on that actually. What do you do for the kids that can't have access to internet or do not have a device, or you just send stuff home?
It's the equity issue, and it really depends on your school, right? We have so many. The division bought these IBM yogas, I think they're still called. Yeah, I think.
Yeah.
And basically what it is, we have a lot of them here because we use them in different classrooms. The kids are able to sign them out because there's no kids in school, so they're able to sign that out. That's if they have internet at home, but there's lots of kids who don't have internet. So what they do is the division, I'm just going to hold this up, it's a calculator, but the division, you can sign out a wireless router that the division pays for. So then it goes into their home and they have internet.
Huh. That is, yeah, like the mobile hotspot internet stuff.
It's like, I mean, if you have your phone, right? I mean, you know already, if you have your phone, you can make it a hotspot, but these are ones that we get from whoever we deal with, Westman or MTS, I don't know what it is, right?
Yeah.
They're basically a wireless modem that they can go into the house and then they have internet.
That's crazy. Well, they got to use them responsibly. I guess they wouldn't be using them as in online gaming or whatever the kids use it.
Well, a lot of them are limited bandwidth and limited what you can go on to, right? There's restrictions or guidelines or throttles. I don't know what it is.
Yeah, once you go past the specific.
Yeah, I mean, it's the best that they can do for the people that are
That's
at home.
actually, that's pretty darn smart, actually. I never thought of that because we do have, that's what we're encountering right now here in Grand Rapids is the kids at home do not have internet. They have iPads here at the school that they can sign out, but
But they still need Wi-Fi.
they still need internet, right? Yeah, and like that is a perfect solution in
You have
Frontier.
to check what the school division is doing, whether or not they even have any, right? It depends on the division. I mean, you know, I think you know this already. Every school division has a different amount of money. Some have lots and some have none. There is
Exactly.
no equity across the board when it comes to that.
Yeah, I'm pretty sure Frontier can.
Yeah, Frontier is one of the ones that has a little bit of money.
Yeah, so like they should at least have like a handful of those in the school year that they can send home to the kids because
You'd have to check to see if they have them. Yeah.
yeah, and then I think it's just the one kid in this class that doesn't have internet. So it's not much, like everyone has internet, right? But it's just the occasional one that does not have it, right?
And then that's the ones you're looking for, because when it comes to this whole thing, and this is about education as a whole, it comes down to what's called an equity issue, right? You have to make everything available for everyone, right? It has to be equitable across the boards. And some are, you know, have more and some have less, and you try to have to balance it out somehow. So
Yeah.
it's a tough situation.
I think we spend most of our tech budget on just developing the school as like this ecosystem where all our devices, like our laptops, our iPads, function within the school, right? Like within the school Wi-Fi. You take them out, you need permission from this guy out in Winnipeg, and then he has to give you this certain thing that allows you to sign in onto these things outside the school. It's crazy.
It's the same as ours. If I take my laptop home, this one, which I don't because I have a desktop at home, but if I take my laptop home, I had to get permission to be able to sign into the school system at home.
Yeah, and I guess that's just that just prevents theft, I guess. It's one more email that they make us write.
I delete every email I get from. The only emails I read are you're the ones you guys send me. Everything else I delete. You trust me, you'll get tons. You'll learn to which ones to delete.
Well, right now they're getting the teachers on Teams, so they're setting everyone up with their team account, and then it pops up right when they sign into their computer, and then they have all their chats, their messages, their email.
Yeah,
all ready to go.
That's what we use in our school is Teams. But this is what I find, and this is just me thinking out loud, is we have so many platforms out there that kids have to do this, and adults have to do this. You got to go to these many platforms to get your messages because there's so much crap coming at you, right? That's why when I developed this course, I decided to use my website, right, which is linked to YouTube because everybody knows YouTube, right? And the ZipGrade. That's all I use because I want to keep it as simple as I could for you guys. So.
And yeah, I am a big fan. I never knew that ZipGrade even existed. Like that is a little nifty little app.
There's other programs out there. That's a free one, right? I mean, I paid a little bit of money to get the next level up, but there's better ones out there that you can pay money for that are better and better and better.
Yeah, the one that you have right now is it's good. I like it.
It's really user friendly. It's a very simple program and it's pretty user friendly. So
it was just a little. You just have to make sure you're putting your dot in the right question. That's the only thing I found.
Yeah, you got to be careful with that, and that's why there's that review function at the end, so you can see. Oh crap! Look, I put A and B on that one. That should be the next line down, and then you can fix it, right?
Yeah, it's real good. Actually they just introduced Kahoot to us last week.
Oh, Kahoot. That's a great one.
I'm actually that's what I was working on. Sorry, I wasn't practicing, but yeah, I was working on my Kahoot quiz tomorrow, I take whatever I taught them throughout the week, and then I put it in a Kahoot quiz, making it fun. And that kind of helps cement what I taught them throughout.
Oh yeah,
right?
it's the basically the it's the activating exercise, right? You're trying to activate what they already learned, right?
Yeah, exactly. And it was I signed up for free, and yeah, it's all right. I think I might even go up one level. I think it's the pro. I think it's like $70 a year or something like that.
Still pretty cheap for
something that you're gonna probably use on a weekly basis, right?
Yeah.
Hey,
So I think
sorry, Brian, can I ask a clarifying question, please?
No.
It's question
Why would you say
13.
no when you laugh at me? What's going on? Yeah, go ahead.
Yeah, I assumed you were joking. It's question 13. It's like absolute x plus 5 equals 0, but there would be no answer. Is that correct?
Wait, 13 on the assignment?
No, on the practice question.
Hang on. On 5.1?
Yes.
13, which 13A or 13? What do you got?
13C. It's absolute x plus 5 equals 0, but that wouldn't be anything, right?
Right.
So
Can't.
it's like,
You can't do anything. So there's no answer to that question.
oh, okay. See, they give you the answers in the books to like the first question, but never to the ones that are actually difficult. And so it's
Oh.
not very helpful.
Okay, I'm going to say something about this book and I'll probably get myself in trouble. I started teaching this course, right? It was a requirement. This is the university requirement that I use a textbook. And this is the one they've been using for contemporary math for years. And one year I decided, screw this. I'm not using the textbook. I'm going to, use the questions that I have, and I'm going to get, the students to buy. Remember, I think I showed you, what was it? Boxcars and One-Eyed Jacks. Remember I showed you this book from last week, whatever it was. So I was going to get them to buy all that. I got in so much trouble from the university. No, this is a university course. You need a university textbook. I'm like, oh, good grief. So they make me use this textbook. I don't like it. Honestly, I don't like it.
That's really weird because a lot of other profs have done that. They've sent us manipulatives. They've sent us like packages to not use the textbooks.
But here's the deal. Most of those courses you probably took were education courses. Is that correct?
No, one is like astronomy, for example.
Okay, because this math course is under the math and science department at BU, and they're pretty stinking picky when it comes to that stuff. I've had arguments with them many times. So I struggle. I mean, it's a really good resource in that if you get into teaching math, there are some really good concepts in there that we talk about in class, but they just extend them further into the book, right? Because everything I'm covering is in the book, but then there's more to it, right? Like of how to, like number lines and questions like that. There's lots of good resources in it. I just don't think it's the best possible book out there. That's just my opinion. So, okay, we gotta get moving here. We only got a half an hour left. And I have like 3 hours worth of work to cover in half an hour. Okay. You ready for it? I'm just joking. It's not that much. Okay, let's talk about multiplication and division. This is kind of the main rules, and these rules. They're slightly different than the addition subtraction. These are the ones you know. Okay, if you have a positive and you times a negative, you end up with a negative right there. Positive times a negative, you end up with a negative answer. If you have a negative and you times a positive, you end up with a negative answer. So in that case, it doesn't matter where the negative is. If you have one negative and one positive, when you multiply them, you end up with a negative. If the signs are the same, so for instance, you have a negative and a negative, when you multiply them together, you get a positive. And the only one that's not on here is, what do you get when you get a positive times a positive? Well, that's because it's already a positive, right? So if the signs are different and you're multiplying, negative. If the signs are the same and you're multiplying, the answer is positive, right? Most of you, I think, do you remember that rule? Yeah, thumbs. Do most of you remember that rule?
Yep.
Okay, good. Okay, now, This next part is the old rules. We're coming back to the rules again, as in closure, commutative, associative. Okay, let's do this. Closure. If you have an integer and you have an integer and you multiply them, you get an integer. That's the closure property, right? It's the same with a whole number or a whole number. Doesn't matter. When you multiply them, you get an integer. Commutative. 5 times -7 is the same as -7 times 5, right? It doesn't matter the order when you're multiplying. That's the commutative property. Associative, it doesn't matter where those brackets are, right? R times ST is the same as RS times T, right? So those rules are identical to what we've done already. Closure, commutative, associative. Then I think the next one, when Lacey and I were talking about this before, the next one was the old distributive property, right? So if you have an R out the front, it means R times S plus R times T, and you can see that. That's the distributive property. Anything on the front, you distribute to everything in the brackets. It's kind of like when you did bedmass at one time and you learned to get rid of the brackets. That's the distributive property. Okay, now there's two more that we've kind of talked about before when we did addition and stuff, but these ones apply to multiplication. I'll put them both up here. The multiplicative identity property of 1 and the multiplicative identity property of 0. If you take an integer and you times it by 1, you get in it the same integer, right? So -25 times 1 is -25. 7 times 1 is 7. It makes no difference. Now, if you take an integer and multiply it by 0, which is the next property, you end up with 0, right? 7 times 0 is 0. -25 times 0 is 0, right? You know those rules already, but we're just putting names to them. Multiplicative properties. That's all it is. And multiplicative just means multiplication property. That's all it means. So it's something fancy. Okay. Let me look at one thing here. I just want to. I'm just looking at the time frame. I want to give you some time to work on this next unit. I'm thinking this next number line stuff is actually not the most important thing to teach you right now. Give me one second. I'm just looking at the exercises. I got to remember. Yeah. Okay. Well, we'll go over it pretty quick. Okay. So this is going to be. It's kind of crazy. This one. These are the positive times positive, positive times negative, negative times positive, negative times negative rules when it comes to number lines. And this may be somewhat confusing when you look at it. To me, when I would do this, I would basically look at these rules here. Oops, not these rules here, right? That's the rules I would look at. Negative times positive, positive times negative, negative times negative. But if you want to see what they look as number lines, let's take a look at them. There's the first one. 3 times 4 is basically 4 plus 4 plus 4, because that's all multiplication is repeated addition. That's all it is. You can even talk about skip counting. It also works. So this one, if you look, we go from 0 and we go 4, we go 4, we go 4, right? Because there's 3 of them. So we end up with positive 12. So then you can show the numerical example here. 3 times 4 is 12. Okay, that one makes sense. Positive always makes sense. Now let's do 3 times -4. So we're going to do 3s. We're going to do 3 of them, but we're going to do -4. So in this case, we go backwards, right? We go from 0. There's our 4 negative. There's our another 4 negative, and there's our other 4 negative, right? And then we end up with our -12. So positive going forward makes sense. Negative coming back makes sense. 3 times -4. Now, this is where it gets kind of weird. -3 times 4. Here's the deal. If you notice, these negatives went to the left, right? Positives go to the right. So this one, we have our 4 here, right? Which is positive 4, but we're going -3, so we're pushing them to the left. So when you look at this number line, it's going to look kind of weird. So if you look, you see our arrow here it's going, there's our positive 4 because it's going from the left to the right. And this one is from the left to the right, but this one is the left to the right. But why did we go -3? Because we're going that way with them. So the arrows don't make much sense, or will make make a little bit difference in that one. So you end up with still your negative 12. So it's the same way as if we did this one here, but these arrows went to the left because they were negative. These ones here, the arrows go to the right because they're positive, but we shift everything to the left because they're negative. Okay. Now, the tricky one is, oh boy, negative and a negative. This one's going to throw you. So negative times negative. So it's the negative, negative 3 times negative 4. Oops, as I went right by it. So this one, right, our negatives are backwards, but we have to go to the right because we're reversing them in this case. Well, that doesn't make any sense. You just said the negative 3s all go to the left. I said, yeah, but in this case, they go to the right because of the negative 3 and the negative. I know it's confusing in that one. So here's the deal. When you're teaching this with number line, the first ones, let me back up. The first ones are they'll make sense to the kids quite easily, right? Those and those ones. These are the ones that you're really going to have to pay attention to where they're going. The other option is like I showed you, could you just talk about the rules instead? Could you talk about those rules instead? Yeah. That would probably be the easier way to do that one, because that last one is quite tricky to understand. Okay, now, those are the rules for multiplication. What are the rules for division?
Same.
They're exactly the same. So you don't have to worry about that. So the rules for division, we'll get to them right here. The rules for division is what positive divided by negative, negative. Negative divided by positive, negative. Negative divided by negative, positive. Here's what you remember. If the signs are the same, it's positive. If the signs are different, it's negative. That's all you got to remember. Okay, so let's do just a quick example, and then you're going to do a bit of questions on this because I don't even know if we're going to get to the activity. That kind of sucks, but let's do these ones. Or no, the answers are there. Negative. So first off, before you even do the math, what's a negative divided by a negative?
Positive.
Positive. So you know negative 24 divided by negative 8 has to give you a positive answer. And then 24 divided by 8 is your 3. Okay. Positive divided by a negative, signs are different. You're going to end up with a negative, right? Negative 3. Positive divided by a positive, the signs are the same. You're going to end up with a positive. And the last one there, negative divided by a positive, signs are different. You should end up with a negative. Okay. The rules for division are exactly the same as they are for multiplication. Okay, so here's what I want you to do. I know I kind of rushed through that because we're running out of time here. Is go to 255 and you're going to do some of these. So these multiplications shouldn't take that long because all you're doing is really just looking at whether they're positive, negative. The only question that might take you a bit of time is 9 because it was the ones with the arrows, but if you don't want to do them, don't stress. It's not a big deal. And then 26, what's 26? Is it 26? 26 is one of those complete the pattern ones. Comes back to critical thinking again. Oh, every chapter, every exercise comes back to a little bit of critical thinking. So give those a shot. And then I want to do this activity. This activity should clarify a whole stack of stuff, by the way. Hopefully we get to those. What time is it? Ugh. I'll give you just 5 minutes to work on these ones. I know that's not lots of time, but I want about 15 minutes for the last activity.
I know we've talked about this before, but on the assignment for question 25, is it like minus 10 take away 8?
Hang on. So negative absolute value minus the absolute value of -8. Okay, so what's the absolute value of 10?
10.
So then the negative becomes -10, right? So your next line would be -10, right? What's the absolute value of -8?
8.
So then it would be subtract 8. So your next line would be -10, subtract 8. That would be your next line. And then just do the math after that.
Okay, thanks.
You're welcome.
For the question 23 on the assignment, should I turn it into the absolute value after I did a addition?
Hang on. Here's the deal. The absolute value signs are around the outside of it, right? So you have to do with everything within the absolute value signs first, right? So the -11 plus -17, now you're going to get an answer in there, and then you're going to take the absolute value of it.
Okay. Thanks.
You're welcome. Oops. Just another minute, and then we're going to switch to the activity. I mean, you might have to do some of those. You might have to do some of those questions after the class. They're pretty straightforward, I think.
Sorry, when they say mail time, what does that mean?
What?
It says describe mail time situations.
What are you talking about? I don't know what you're talking about.
I'm looking at, oh, sorry, this is 5.2.
Oh, the questions. Okay, sorry.
Yeah.
So give me a
and it
sec.
says-
Sorry.
Yeah, a bunch of them say mail time, and I don't know what mail time means.
Which question? 5.2. Oh, I actually don't know that. Give me a sec. Mail time. Describe mail time situations. Give me a sec. Sometimes they use words that don't make any sense, and sometimes they don't make sense to me.
I was wondering if it's like a check and a bill.
That might be what it might. That you're right. That's what it might be. Oh, yeah. Look at. Oh no, you don't have the book. Yeah, you have the book. But on page 235, it says at mail time you receive a bill for $2 and another bill for $4. Are you richer or poor? So all they're talking. Wow, that is old school. So in the mail, when you receive, nobody received. I don't even know if people receive mail anymore. At mail time, so in that case, you got to you have a bill for $27 and another bill for $13. How much do you owe? Well, you're poorer by that amount. That's all they're saying.
Okay.
At mail time. Yeah. Okay. Okay. That's
you.
just dumb. Oh, you're welcome. Thank you for asking. That's just a dumb. That's a dumb way of wording that. It tells you how, like, I mean, they do different editions of this book, but they need to update it to, you're paying for your Twitch account and you need to, well, I guess modern day. No, what is it? What is it? Hashtag Snapface TikTokogram, right? It's that account, them all together. You got to pay your money, I guess. Okay, let's do an activity here. So let's kick out of this. So where I want you to go to is, let me share the screen. Back to the main page here. And what we're going to do is we're on, what are we on? Day 7. So the colored model chip activity is what I have in front of me here. You can print this off if you want later, but I want you to go to the colored chip website. So click on the colored chip website. Now, these ones are not red and black. These ones are red and yellow, but the same concept is there. Okay, so yellow is going to be positive. Okay, +1. Red is -1. So if I put those together, well, make sure you. Oh wait, how are you gonna do that? Because you got to watch me, but you also got to do your. Can you see? Can you go to the web page and see me, or see my screen, or is it two different things? Sorry, I got to double check that.
We can see you.
Like
And
you
the
can,
screen.
you can see, but you could, but you can't. If you were to go click on that website yourself, you wouldn't be able to see both, right? Is that correct?
I mean, if you have the screen, yeah, you'd be
Oh,
able
okay, if
to.
you have the screen. Okay, so maybe just watch me do this because that might be the easiest way to explain it. Okay, so for instance, if we wanted to do addition, so let me get rid of this here. How do you get rid of this? Undo. Okay, so if I put this, remember, you might have to just remember this. Red is negative. Well, just think about this. When in business, they talk about being in the red, right? Which is like when they do the books, black is positive and red is negative when they talk about accounting. It's a common term. In fact, that's why if you actually get down to a Black Friday in the US, the big holidays, it's a reason because that's where they start making money. That's why they call it Black Friday. Okay, so if I put this on the screen, what is that? These are positive right away. What does that represent?
2.
2. Okay, now if I also put this on the screen, watch here. This also represents
2.
2. Doesn't change, right? Because these two here, right? They cancel each other out. Okay, so for instance, if I wanted to add, hang on a sec here. Where's my first question? I want to find the sum. Let's get rid of this. I want to find the sum of 3 plus 1. So if I do this, there's my 3, right? Then I want to add to it +1 because they're all positive. can you then see that the answer is +4? So +3 + 1, +3 plus +1 is +4. Yeah, you can see that? Hopefully. What about negatives? What if I said -5? Oops. -5 plus -2. Does that work? Can you see that the answer then is what? -7? Okay. So addition works really well when you're dealing with, let's say, positives and negatives. Now, here's the kicker. What if you want to add positive and negatives together? Watch how this works. So I want to add -4. Okay, here's my -4. And I want to add +6. And again, you would show this with the pictures like this, but you would also put the numbers underneath them, right? You would put -4 plus -6 because they need to see both, because eventually you want to get them away from the visual one and right to the numerical one. Okay, so here what I want to do is I want to add -4 and +6. So what do I need to do?
Pair.
I have to hit what, sorry?
Pair up.
Pair up. Every pair I take is a 0, isn't it? So look, here's a pair, it's gone, right? Here's a pair, it's gone. Here's a pair, they're gone. Here's a pair, and it's gone. And you can get rid of this however you want, right? I wonder if I can just delete them. I can't. So what am I left with? +2, right? So there's the great, this is what we were talking about before when we were doing all the little discs, right? So -4 plus +6 yields you your +2. Oh, that's awesome, right? Because that's the nice way to show addition. So if you're teaching addition of positive and negatives, this is a great way to show visually what it means. Okay, does that make sense so far? Okay, let's try subtraction. Clear all this out. Okay, so subtraction. So for instance, let's say I wanted to put +3 subtract +1, right? +3 subtract +1. So here's my +3. How would I subtract +1? Could I just do that? Yeah.
All right, all right.
Well, no, we don't need to in this case because we're just subtracting. So for instance, if I have +3 and I want to remove a +1, I take it away, right? So what am I left with? Yeah, my +2. Basic subtraction. What about if I wanted to add -5? Here's my -5, and I want to subtract -2. So -5 minus -2. Does that just allow me to take 2 of these away?
Yes.
Yeah. So if I take 2 of those away, right? -5 subtract -2, I end up with my -3. So that works really nice if it's the same, right? Negative subtract a negative or a positive subtract a positive. Now, here's where it gets tricky, right? We're going to start doing positives minus negatives or negatives minus positives. So let's do this one here. Where's the one I want? So let's say I wanted to, let me clear this off. Let's say I wanted to do, and you might want to write this down just so you have it in front of you or just remember it. +2 minus -3, right? So +2 minus -3, right? This is how you show it with these numbers. So first off, we need to start with 2 positives, right? So here's our 2 positives. But the problem is I want to take away from here. I want to subtract 3 negatives. I don't see 3 negatives on here. Do you? No. So what we do is we can add pairs. So watch, what I'm going to do is I'm going to add a pair. I'm going to add a yellow and a red, and I'm going to add another yellow and a red, and add another yellow and a red. Now here's the deal. My +2 didn't change, did it? Because that first red and the yellow and red is 0. This yellow and red is 0, and this yellow and red is 0. Yeah, those are all zeros, aren't they? So my answer is still +2. Like I'm starting with a +2. Yeah, that doesn't change. That with the 1, 2, 3, 4, 5 yellows and 3 reds is still +2. Now, here's what I want to do. I want to take away. I want to subtract 3 negatives. So what colors am I going to remove? How many? What color and how many of them?
2 red.
No, I want to take away 3. But did you say 2 or did you say 3? I didn't hear that. Sorry.
The 3 red ones.
Yeah.
3 red ones. So bang. So we're taking away the 3 red ones. So +2 minus -3 ends up being, what's your answer? +5, right? And again, this is visual, right? But you would also show the numerical way of doing it. Okay. What's the next one here?
Why is it +5?
Okay, let's do this again. So we start with, what was the question? +2, right? There's my +2. And I want to subtract -3 out. I want to subtract 3 red ones. But if you look, I only see 2 yellow ones. I don't see any red at all. So what we have to do is we have to add in 3 red ones. But to do that, we always have to add in pairs, right? So here's my first pair, which is 0. So that's still, this thing here is still -2. That doesn't, sorry, that thing right there is still +2. It doesn't change. So then I add in another one. Yeah, there's my other one. That's another 0. So this is still +2. And then I add in my third one. And this is still +2, right? Because all of this stuff here, all of this yellow, red, yellow, red, yellow, red means 0. It doesn't mean anything. Okay, so you understand that part, right? Yeah? Okay, so now what I want to do is I want to take away, I want to pull out of here, I want to pull out 3 negatives. So if I pull out my 3 negatives, my negatives are, look, my negatives are my red ones, right? So I pull out 1, 2, 3. So what am I left with for my answer? +5, right? Does that make sense?
It's better.
Okay. What it is, again, if you are doing this with kids, are you going to do it in 5-10 minutes? No. Are you going to take a couple classes to do this? Yeah. Just on addition, probably, right? Subtraction is another 3 or 4 classes. Multiplication, half a year. Well, not probably half a year. Okay. Okay. So that was, and I'm just kind of flipping through these pretty quick. We'll do multiplication and then we'll call it for the evening, because then I don't want to go, I never want to go over time. I never want to waste your time. Okay. Multiplication is kind of cool. So if we wanted to start, and I got to write these down so I have them in front of me. If we want to start with +2 times +3. So +2, +2 times +3. What that means is I need 2 sets of +3, right? 2 times 3 means 2 sets of +3. So here we go, 2 sets of +3. So there right here, that's one set of +3, right? And I'm going to add to it another set of +3. So 2 times 3, or 2 sets of 3, yields us +6, right? You see that? Okay, now, what if I say instead 2 sets of -3? So I'm saying +2 times -3. +2 times -3. So that means I want 2 sets of -3. So now I'm going to switch to the red. So here is one set. That's one set of -3. And I need 2 of these because that's 2 times -3. So now I need 2 sets of -3. So you can see right away, +2 times -3 yields us our -6. So these are the kids you're going to be doing this with that really don't understand the positive negative thing when you're multiplication, right? This is a good way of doing it. Okay, now it's gonna get a little trickier. If you can hold on for 1 more minute, I know I'm almost over, but I want to do for you -2 times +3. So this is different. -2 times +3. Now the -2 in front, it means take away 2 sets of +3, right? So you can write that. So -2 times +3 means take away 2 sets of -3. Well, the problem here is, since 2 is negative, right? What do you have to look at here? You can't just say, I got nothing in the circle, so I got to put something in the circle. So what am I going to put in the circle? You want to take a guess? We're taking away stuff. So what do we need in the circle? Because right now, there's nothing in the circle.
Pair up.
You got to put in pairs. That's right. Because there's nothing there right now. I need to put in pairs. Now watch this for a sec. So I'm going to put in pairs. I'm almost done, and then I'll shut up. Now, if you watch here, this is kind of neat. And this is all that I'm doing is a visual representation of positive and negatives. So right now, in my circle, I have 0, don't I? Because everything cancels out. But since I want to do -2 times +3, I want to take out, 2 sets of +3s. So my positives. So if I do that, if I take out my 2 sets of +3, here I'm taking out 1 set of +3s, right? So I got 1 set of +3s. And now I'm taking out another set of +3s. Oops. And what am I left with? -6, right? Which makes sense, right? Because we know that -2 times +3 is -6. Okay. I know, I'm sorry that I rushed through that. I wish we had more time. If you really are interested in it, let me show you. Go back to the web page here, and I've included the colored chip model activity. So if you click on this one, this is what I was talking about. This is where I'm getting this stuff from. And you can go through this and you can actually see all the different steps and to see addition, subtraction. Here's multiplication. This is what we were just doing. And there's even some on division, which is really kind of tricky.
Hey, Brian.
Yeah, Sam?
Do you mind if I just log out really quickly? I have to go do something right away.
No, 7:30. Log out. Go.
Okay.
Yeah, sorry. I didn't mean to keep you.
No, we just have something to do. I'm on a farm here, so we're pretty busy right now. But
yeah, go. Get going.
Thanks.
Get going. We'll see you tomorrow. Okay, so sorry that we went a little bit over. I apologize. I will save this and throw it up on the recording for tomorrow. If you want more practice, do that. In the meantime, remember, the assignments are due tomorrow at 8 o'clock, which means at the end of class, because that's when I'll print them off. And I think I already got an assignment from somebody anyways. Who sent me one?
Brian.
Olivia, I got yours. Sorry, who is that?
Okay, good, thank you.
Oh, hey, Farah. Yeah.
Hey, so we're having a vaccination clinic in our community tomorrow, and I work at the health center here, so I'm a part of the vaccination team that will be doing the clinic tomorrow. So I do have my assignment done and ready to hand in. Can I just email it now?
Oh yeah.
And can I just check out the recording for tomorrow's class? Because I'm pretty sure the clinic goes until 6, so I may miss like an hour or so.
That's fine. Okay, so here's the deal. Yeah, send in the. You can always send in the assignment ahead of time. No problem with that.
Okay.
If you miss the whole lesson tomorrow, like the video lesson, I mean, I will mark you absent.
Yeah.
But if you show up, I will mark you there, and the video lesson will be available Friday for you to listen to.
Okay.
But that's fine. The vaccination clinic takes priority. I hate to say, sorry.
Yeah, for sure. Okay, all right, thank you. Well, I will hopefully see you tomorrow, probably after 6.
Awesome. Yeah, if you come after 6, that's fine too.
All right, okay.
I have a quick question.
No. Oh, of course, Alice, you can ask. I'm just joking with you. Yeah, go ahead.
For question 20 in the assignment.
Which one on the assignment? Sorry.
Question 20.
20?
Yes.
Sorry. Sometimes I don't know what it is. It's your mic. It's kind of muffled sometimes. I don't know what it is. Is it one of the? Is it one of the ones that sits on the computer? Is that what it is, or?
Yes.
They're not the best. So sorry. Question 20. Go ahead. Yeah.
The x is in absolute value. So if it's positive, it stays the same, right?
Okay. So what do you think one of the answers is?
It could be a positive answer. Should I say it?
No, but what? Give me a value of x that when I take the absolute value of it and subtract 6, I get 1.
Yeah.
So what could x be?
7.
That's one possibility. There's another one there.
Oh.
Well, think about it. You can take the absolute value of a positive and a negative number and still end up with the same positive number, right?
Would -7 take with 6 be
Okay.
1?
No. Do it. Do it properly. What is the absolute value of -7?
7.
And then -6 is?
1.
So is there 2 answers? Yeah. What x could be both of those? Because you got to do the absolute value first before you do the subtracting of the 6. Oh yeah, I got to stop recording here. Hang on, give me 1 sec. Let me just stop sharing and stop recording. There we go. Now it'll start doing its thing.
So it could be 2 answers.
Right. X could be 2 possible answers. So you put both of them down.
But there's only 1. Mm,
No. It's asking you what x is. There is 2 answers for x. And you told me what both of them are.
Okay. But if it's a -7, then it won't be 1.
But you're not doing the -7. You have to take the absolute value of -7 first, which is +7, and then
Yeah.
subtract it from 6 and you get your 1.
Yeah.
That's the tricky part of that one, right? That's what you got to realize.
But that's only one way.
Yeah, but I can't remember if I put any more in there or not of those ones. So. All right, let me get myself organized here.
Thank you.
You're very well. You're welcome. That one. This goes here. This goes here.
To be honest, the
Brian?
multiplication is a lot.
Sorry, hang on a sec, Justin. Sorry, what was that, Alice?
To be honest, multiplication and division is a lot easier for me. Maybe I remember it.
Yeah, it'll come back to you. I mean, if you haven't done it for a while, I mean, it'll come back to you.
Yeah.
Okay, Justin. Sorry, you had a question.
I got a couple. I'm sorry
No, you
to
don't.
keep you any longer. I just need to know for question 1, are we looking at a 2-digit number or a single digit? For question 1 for the assignment.
Single.
Single, okay. Because I tried to pump the equation. I don't know what I'm doing wrong here.
Well, no. You could look at it this way. Like, think about 6. What are the only factors of 6? 1 and 6 and 2 and 3, right?
Yeah.
What are the only factors of 10? 1 and 10 and 2 and 5.
Yeah.
And then 18, right? 1 and 18, 2 and 9, 3 and 6. Which
Yeah.
number is the same in all of those?
Okay, that's what I did at first, and then I tried to do the equation, and I think
Either way works. It doesn't really matter which way you pick to do it, right?
Okay, and then another one.
Yep.
Let's see. I think it was the one with the clock was kind of giving me a little number 16. I tried to get the factors, the prime numbers of 14, 22, and 77.
Yeah, but here's the question for you. Either of those, you're going to find the prime factors. Are you looking for the least common multiple or the greatest common divisor?
You would look for the least common multiple, wouldn't you?
Correct. You're looking for, basically the chime is 14. The next one's 22. You want to find out where they line up again, which is the multiples. It's going to be a big number probably.
So I'm taking the highest, right?
Yes. Sorry. Yes. Sorry. I had to think. Least common multiple is the largest. Greatest common divisor is the smallest.
Okay, so I'm taking the highest
16.
there. And I think I'm good. I think I'll submit this to you. Oh, this is another thing that's giving the, I probably just gotta go home and is number 27. What 9 by 9 square are we talking?
Hang on. 27?
Yeah.
Oh, it's the magic square one. We did it on the, it's the 9 boxes, right? And you got to put stuff in the 9 boxes. In this case,
Oh, okay. I was trying to do 9 by 9, which was
no.
give me...
It's 3 by 3.
Okay.
And then every row and column has to add up to the same thing.
I was like, there's not enough numbers here. I'm gonna write 3 by 3 here.
3 by 3. Yeah, it's a standard, like a tic-tac-toe square thing.
Okay, and everything else I believe is good to go. You'll see an email from me tonight.
Well, I won't see it until tomorrow because I'm going home.
Well,
well,
yeah.
sorry, I shouldn't say that. It shows up on my phone, but
yeah. Okay.
I think that's it. Okay.
Brian.
Yep.
Oops, wait. I'm just wondering about the GCD.
Right.
Oh, wait, hold on. Lots of stray dogs. So the assignment,
right,
is due 8 o'clock tomorrow, right?
Yeah, by 8 o'clock. So, I mean, if you have questions at the beginning of class or even just near the end of class, you can ask them if there's a few that you don't get.
Okay, I'm just wondering that.
Remember, for GCD, both GCD and LCM, you got to do that prime factorization. If you don't remember where that was, it was in, I'll give you the exact thing. It was in yesterday's lesson. Well, here, you have the textbook, right?
Yeah.
Okay. Here, I'll give you the page right out of the textbook. So you can kind of, where'd my screen go? Oh, there it is. What was that? 5 point, give me a sec. Just give me a sec. Let me find it in the book here. Oh, no, it wasn't. No, we did 5 today. It was 4, wasn't it? Hang on. Yeah, here we go. Trying to find you a good example to go through. Least common multiples. No, that's a. No, it's actually probably better on the assign. Give me a sec here. Let me open it up. I'll show you the, you can go back and look at the PowerPoint here. Let me find it. There, oh, excuse me. Bolton's math blog, share screen, this one, share. So can you see my Mr. Bolton's math blog on the screen now? Can you see that?
Yep.
Okay. So when you go to contemporary math, like all the PowerPoints are on here. You just have to click on the one you want. So the one we did yesterday, Tuesday, right here. So you can see PowerPoint number 3, 6.4, teacher, right?
Yeah.
So if you click on that, what it'll do is it'll download it to your computer. I think you can see in the bottom left-hand corner here. Double click on that and it'll open up the PowerPoint for you. So this is where the stuff that I did, right? So you can look at it. Okay, now the stuff you want is on, let me find it here. Oh, I got to enable editing.
Is a GCD same as a GCF? Because that's how it feels like I remember it that way.
GCF.
Like a factor, greatest common factor, if I'm correct.
Yeah, greatest common divisor is basically almost like the TCF, what you're taking out to. You'll need to enable the editing of it. Hang on, let me just actually pull up my screen. It's easier. I'm trying to do this with wrong screen on my page here. Hang on, give me one sec. Shared. What was yesterday? What's today? Day 7, day 6 yesterday. There it is. All right, there it is here. So I think the one you want is, let me find the slide here. Okay, so if you go back to slide, where does it start? So 4.3 is where it starts. So slide 19, right? And these are the way, I mean, you can look at it this night. Probably the best idea is to look at it tonight when you have a little bit of time to do it, instead of me just throwing it at you real quick. So I'll kind of go through this. So what you're finding is either if when you're finding the GCD or the LCM, then the initial step is to always do this. You have to find the prime factorization, right? So you have to break the number down into all its prime numbers. And prime numbers are anything divisible by itself and 1. So prime numbers would be like 2, 3, 5, 7, like things like that.
So that's like a tree.
Yeah, the tree. Yes, exactly, the tree.
Can I use a tree for number 1?
Yeah, that's the best. Well, you would use a tree for the 6, use a tree for the 10, use a tree for the 18, right? And get all the prime factors.
So what about the least common LCM?
Okay, so same thing. Do the tree for the 48, do the tree for the 162, do the tree for the 27. But that's the first step for both of those. Okay.
No.
Then what you want to do is you want to write them out. Like if you look at I think you can see my, oh no, I'm not sharing. Oh, sorry, I'm not sharing my screen. That would help if I was actually sharing the screen. Oh, sorry, man. Jeez. All right. So here you'll see 2250. There's our prime factorization, right? 2835. There's our prime factorization. And we did that with the trees.
So, okay, so I write them down. That's the prime factorization.
Right. When you do it with the tree method. Now, what you're looking for, so for instance, if you're doing GCD, you're looking for the smallest of everything. So if you look here, this first one had a 2 to the 1, right? There's our 2 to the 1. This one didn't have a 2, so we had to write 2 to the 0 because we have to fill it in to make sure we know which one to pick. Okay.
Yeah.
So then we pick the 2 to the 0 because it's the smaller of the 2. Then we have a 3 to the 2 and a 3 to the 4. We pick the smaller one, which is the 3 to the 2. That's why it's here. We look at the 5. We got a 5 to the 3 and a 5 to the 1, right? So we pick the 5 to the 1 because it's the smaller one. Now, if you look here, this one had a 7, but this one doesn't have a 7, but we still have to put it in there. So that's why we do 7 to the 0, because if you remember, anything to the 0 is still 1. It doesn't change it at all. So then we go, you look at 7 to the 0 and 7 to the 1, and you pick the 7 to the 0. Okay.
Okay, so so I use a tree on all of them.
Right.
6, 10, 13, and I look for the small numbers.
Of each, if you look, so what's the first one? GCD, you got a 6, a 10, and an 18. If all of them are going to have 2s, right? You have to figure out, okay, let's say I have a 2 to the 1 and a 2 to the 2. I pick the smaller one, which is the 2 to the 1.
Yeah.
And then you look for the other numbers. So that's what GCD, for GCDs, you always look for the smallest ones. Guess what? For LCMs, you look for the
bigger ones.
Right. So here, watch the screen for a sec here. I'll just jump to LCM. So if we jump to the LCM, oh, hang on. Let me get to the right screen here. LCM, hang on. I'm just getting to the right screen. The same as the last. So here's our numbers again. There's our 2250 and our 2835. The only difference is we're looking for the largest ones now. So we had a 2 to the 1 and a 2 to the 0. The larger one is the 2 to the 1. A 3 to the 2, a 3 to the 4. The larger one is a 3 to the 4. 5 to the 3, 5 to the 1. The larger one is 5 to the 3. 7 to the 1, 7 to the 0 is 7 to the 1, right? So the key there is once you do your tree, your prime factorization, then you either pick the lowest ones or the highest ones.
Okay.
So lowest for GCD, highest for LCM. Lowest for GCD, highest for LCM.
Yeah, I'm getting it.
Give it a shot. And if you're still struggling with some more, I'll be on like 15 minutes before class. You can log on and I can give you a little bit more help with it too.
It's everything's just slowly coming back.
And that's one of the if you haven't done math in a while, it's going to take some time to get it back. If you're stuck, I mean, on page 205 in the book, right? 205 in the textbook talks about what we just all talked about, and you can look there and there's some examples. Maybe that'll help you piece some out.
Yeah.
Okay.
All right. Yep. So are you
and the video is up from yesterday if you want to watch it too.
Okay.
The Zoom video.
So are you usually on by
about quarter
15
two?
minutes before
Yeah,
class?
about quarter two.
Yeah. All right. I think that's everything.
And again, like when we're doing stuff in class, like when we do the questions where, you know, when we take time to do the questions, you can ask me questions then for your assignment too, right?
Yeah.
Well, I mean, why not? If it's still valid time. So
Yeah, I'm just a little intimidated.
yeah, try not to be. I mean, I know it's tough, but
it's been a while, so that's
okay.
about it. All right, thank you.
You're welcome. Have a good one.
Right.